Motion in space, position, velocity, and acceleration, and also speed. Define r of t to be the position of an object in n-dimensional space, Rn. Then the velocity, v of t, is defined to be r prime of t. And the acceleration, a of t, is the derivative of velocity, or the second derivative of position. Speed is defined to be the magnitude of velocity, so we could also write that as the magnitude of r prime, or, as we saw in an earlier video, ds dt. Let's do a couple of simple examples, starting with this one. Consider r of t equals t cubed I plus t squared j. Let's find the velocity, acceleration, and speed at t equals 1. Start by finding our velocity. So we're going to find the velocity at t, which is r prime of t. Right, always take the derivative first, then plug in. That's going to give us 3t squared I plus 2tj. There's our velocity. So the velocity at 1 is going to be 3i plus 2j. Let's go in and find the speed using that, because speed is going to be the magnitude of our velocity, and here at 1, which is going to be the square root of 3 squared plus 2 squared. And then the acceleration at 1, we start by finding the acceleration at t, take the derivative first. So that's going to be v prime of t, which will be 6ti plus 2j. So our acceleration at 1 will be 6i plus 2j. One more straightforward example. Suppose we know the acceleration this time, which is 4ti plus 6tj plus k. And we know that the velocity at 0 is I minus j plus k. We want to find, I said r of t, let's find r prime of t. So r prime of t is, of course, v of t. So I know that v of t is going to be v of 0 plus the integral from 0 to t of my acceleration function, and I'll put in our dummy variable u like that. So v of t will be my initial velocity. I'm going to change to the other notation, which would be 1, negative 1, 1, plus the integral from 0 to t of each piece individually. So I could do the integral of 4t, which is going to be 2t squared. Let me go back here because I do have a dummy variable, so it's going to be the integral of 4u, really. So 2u squared from 0 to t. I'll try and get my details to all match up. And then the integral of 6t, but it's really with my dummy variable u, so I'll have 3u squared from 0 to t. And the integral of 1 with respect to u will be u from 0 to t. Let's do a little bit more work. Put my starting point down again. Plus, then we have, plug in the top limit, 2t squared, minus the bottom limit, 0, comma, plug in the top limit, 3t squared minus the bottom limit, 0, and then comma, plug in the top limit, minus the bottom limit, gives us just t in the back part. So the velocity vector would be 1 plus 2t squared, negative 1 plus 3t squared, comma 1 plus t.